Okay, what I'd like to talk about today is derivative notation, and this is notation for the function y equals f of x. These are actually two different kinds of notation, and back in calculus you learned two different kinds of notation for the derivative. The first is called the Leibniz notation, named for the guy who wrote the first calculus book, and the other is just plain old function notation. In Leibniz notation, the first derivative is written as dy over dx, which represents the change in y over the change in x. In function notation, it's written as f prime of x. The second derivative is written as d squared y over dx squared, or f double prime of x. And the third derivative would be d cubed y over dx cubed, or f triple prime of x. These are the two standard notations, and it goes on and on from there. Fourth, fifth, sixth derivatives. In the real world, you almost never get anything past the second derivative, though. Now, most differential equation textbooks use a hybrid notation, sort of a combination of these two, where the first derivative is indicated as y prime, the second derivative y double prime, and the third derivative y triple prime, and so on. The main disadvantage of this hybrid notation is you'll notice that there's no mention of the independent variable x. In Leibniz notation, we have the x's in the denominators to remind us what the variable is. In function notation, you've got the x's in the parentheses, but you lose that in the hybrid notation. A lot of times, in fact, the variable is actually t for time, but there's no indication of that variable. Now, I mentioned Leibniz earlier, the first guy who wrote a calculus book. You may remember, though, that Newton was the first person who developed calculus. He just never published anything about it until after Leibniz did. And Newton had his own notation, and for a long time I really thought that nobody used Newton's notation anymore, but it turns out that because Newton was a physicist, physicists still use Newton's notation. And you'll find that one of our project labs uses the Newton's notation also. Newton used x to represent the function. It was usually a function of time. And his derivatives were indicated with little dots above the x. So the first derivative was x with a dot above it. The second derivative was x with two dots above it. The third derivative would be x with three dots and a little triangle above it. It was kind of weird notation, and like I said, very few people use it anymore, except for a few physicists. You'll see it every once in a while, though. So I just wanted to clarify the different notations that we're going to be seeing, and that's about it for this video. Thank you.